All right, so we still have some redundancy. We only just moved plus, right? We still have a couple more methods to look at. We do have a couple of functions that are converting from hour, minutes, and seconds down to seconds, or backwards, right? Forwards and backwards in some of these functions. So let's look at how we could deal again with this redundancy, right? And you know, when we say redundancy, right? These are examples of redundancy in source code, right? But that, you know, redundancy is pervasive in all areas in software engineering and elsewhere, and it's really you know, as I said, you know, it breeds inconsistency, right? Even in, you know, in databases, I'm sure if you've taken databases, one of the things that we drill into students is eliminate redundancy, right? And we looked at all sorts of techniques of how to split the structure, the data structure, so that, you know, whenever you're storing a piece of data, it's only being stored once, right? That when you do a query to a database, right, that that information is only stored in one single place, right? That there wouldn't be, you know, if you're doing certain queries that that presumably have to answer the same question, it would be inconvenient that two queries that are supposed to be the same come back differently, right? And that happens if you have redundancy, right? If you have you know, if you have a family living in the same house, right? Typically they'll all have the same address. So how do you structure that? Do you store the address with a person, and then you have the address just copied and pasted many times if you have 5 folks living in the same house? Or instead, perhaps you store the address in one single place, and then you make references back to who they belong to, right? So all these the notion of eliminating redundancy, of storing things multiple times, right? It's pervasive all throughout our industry, right? Of eliminating it because it breeds inconsistencies. So here's just examples in source code. Right. So let's take a look at some of the other methods. Here we have asHms, right? We want to be able to take the, in this case, we were doing some minor arithmetic where we were converting locally from seconds, right? In CompactDuration, where we only have seconds. That's all we have, right? We converted from seconds back to hour, minutes, and seconds, and then we formatted it into a human readable format, right? So we have this, so that's there, and somebody, you know, had a keen eye and said, wait a minute, I think I saw that somewhere else. You know, that source code looks very, very suspicious, and in fact it says, oh yeah, I remember, it was in my DurationImpl constructor, right? In my DurationImpl constructor, I remember that same exact piece of code, right? Where we were there were 2 constructors, right? In the DurationImpl, one that took hours, minutes, and seconds, right? And then we had another constructor that took on just hours. Yes, I mean not hours, seconds. Sorry. And then we had to run the we had to decompose the seconds back into our constituent hours, minutes, and seconds instead of DurationImpl. Remember that, right? So wait a minute. So that code looks identical to that other code in my HMS in the CompactDuration, right? So that's redundant, right? That piece of code is redundant. So same thing in the asHms for the DurationImpl. You know, we do have the same formatting, right? Hours, minutes, and seconds to generate it for human consumption, right? So whenever we see this, right, immediately a flag should raise and say, well, how can I group this into one central place so that if I'm going to have to maintain this at some point in the future, there'll be one single place where I can do that. These are a bit easier, right? They're just perhaps we should be able to just create a function, right? One single function, move this over, and then just reuse that. And that's exactly what we're going to do, right? We've identified that, you know, CompactDuration asHms, right, uses the same code in the constructor and as some other asHms in some other class, right? So yeah, and definitely we want to move this into some helper methods, right? We want to encapsulate it in some helper methods so that we have one single point of maintenance, right? Avoid redundancy. Redundancy breeds inconsistency. All right, so let's take a look at this. One of the things that we could do is create a helper method, right? Helper method that in a central place, right? Perhaps in the abstract, move it over to the abstract class and provide an implementation that is static, right? That you pass it the values, hour, minutes, and seconds, and it can generate the format for you. Okay. So now this algorithm of going from hour, minutes, and seconds, right, to a string is in one single place, right? And we can make it independent of any particular instance, right? It doesn't need to know that it's a CompactDuration or DurationImpl. It doesn't really matter, right? It's just formatting. You pass it some values, and then it gives you always the same string, right? There's no point of it living in every single instance, right? So we can move it over to a static function in the abstract duration. Now that we have this, we can go back, right? And everywhere where we had this formatting, right, we can replace it with so that they access this static method instead. So everywhere, where was it? Everywhere where we had this formatting, such as in CompactDuration, right, as the asHms, instead of it doing any formatting, it just passes it along. It passes it along to the abstract implementation, passing the specific in seconds, right? I skipped over a function here that has to be able to convert from the seconds implementation onto how do you convert it back to hours, minutes, and seconds, right? And so we can use this static implementation asHms, as long as you can pass it hours, minutes, and seconds, right? It'll just do the right thing, right? In either the CompactDuration and DurationImpl. The other thing also, right? We notice that this conversion of going from hours to minutes and minutes to seconds and adding everything up into a whole bunch of seconds from hours, minutes, and seconds, right? We can also spread it. We can extract all that logic again into some helper functions, static version of these functions that know what the arithmetics are, right? Of going from hours to minutes, from minutes to seconds, and whatnot, right? And be able to convert everything back to its canonical format of just seconds. Yes?
What's the difference between the static, declaring implemented static, and just putting it in the abstract class and then implementing it so that all the...
Well, we are putting it in the abstract class.
So you are doing it.
Yeah. All this is in the abstract class. Yep. And static is because they don't need access to any particular instance. It's just a function, right? It doesn't need to know about the particular entity or uniqueness about that particular instance. Right? It doesn't need this. Right? You can just pass it whatever values you need, right? And it'll be a straight function. Yep. So here we're passing along the in seconds, right? And we can convert it back to hours, to seconds, to minutes. Also notice that one thing that has been lingering on for quite a bit that we never dealt with, right, was that when we were doing this division, where we were dividing the in seconds, right, and we never checked, we never verified or validated if that number was way too big, that somebody might pass in some huge number that even if we divided by 3600, it still could be a very big number, right, because we were trying to convert things that were in long, which is, I don't know, that's 32 bits or something, right? And we're trying to fit it in something that was an integer, right? That was only 16 bits, right? And so we could not fit the size. So there could be an overflow, right? We never dealt with that, right? We just accepted that as a possible bug, right? Well, here we're dealing with it, right? We're saying, all right, but pass me seconds, and it could be that even if I divide it by 3600, I might have an overflow, right? It doesn't fit into my integer, right? So that when I go down to an integer, right, this casting might fail, right? Because it's not enough space for it. So we're validating here. We're finally biting the bullet and say, I'm catching it here. If it's too big, I'm just going to throw an exception.
Does Java have any primitives or built-in classes or anything for larger numbers than long, like 64?
Yeah, there's big ints. There's numbers that are arbitrarily large. that will grow as you instantiate bigger numbers. If you want to calculate pi or something that are infinite sequences. Yep. The dedicated classes, big int, big long. There's big versions of them. They all start with big. So once we have these helper functions, we can now very easily go back and implement asHms and on both CompactDuration and DurationImpl, so that we can convert back from in seconds in CompactDuration. We can convert it to hours, minutes, and seconds, so that we can pass it along to our helper function. Or if we're in DurationImpl, we already have them. We already have the hours, minutes, and seconds, right? So we can just pass along our local fields, right, so that we can format it. Same thing with DurationImpl, where we were also doing some arithmetic in there. No longer, right? No longer do we have any duplication of the source code. Instead, now we're using the static versions, right, of conversion of the in seconds, right, from this syntactic sugar convenience constructor, right, where we are passing now in seconds and then converting them down to the constituent hours, minutes, and seconds, right? So again, so we've removed the redundancy. We have been able to move over onto the abstract duration all the extra implementation of our methods. Some of them depend on specific implementations from the specific version of your duration, right? That, for instance, from seconds will have its specific different implementation as CompactDuration. Okay. And the end. Very good. Awesome.